Hey guys, so today we are going to discuss the question called as coin change. So this is a Leetcode medium question. So this is also a very important question, a very famous question. So let's start reading the question. So you're given an integer array called as coins representing coins of different denominations and also an integer amount representing total amount of money. So you have to return the fewest number of coins that you need to make up that amount. So if the amount of the money cannot be made up by any of the combination of the coins, return -1. So what they're trying to say is, and also importantly, you may assume that you have infinite number of each kind of a coin, right? So what they're trying to say is they'll be giving you an amount. They'll be giving you an amount. It's an integer value, right? So along with that, they'll be giving you some coins in the form of an integer array, right? So you have to find the minimum number of coins you can take from those coins and make up that amount with some of that amount. For example, let's take this example. So here we are having an integer array called as coins, which are coins which would represent coins. So we also have an integer value called as amount, which would represent an amount where we have to find the minimum number of coins that we have to take, which would sum up this amount, which would make up this amount. That's the requirement, right? So as they're trying to say, you have to find the fewest number of coins, right? That's the main case. You have to find the fewest number of coins. So whenever they ask you to find the fewest number of coins or minimum number of coins, you always try to take a coin which has more value, right? Largest value, right? For example, let's take, we have a 7 rupee coin here. It's the amount is 7 rupees, right? So now there is one combination where you take 7 1 coins, which will make up, like, for example, like so on 7. Let's assume there are 7 1 rupee coins. So now if you sum up these ones, it's going to be 7, right? This would be one combination. So similarly, there will be many combinations. For example, if you take 1 6 rupee coin and 1 1 rupee coin, this is going to sum up to 7, right? This is also one combination. So if you see comparatively here we have used 7 coins, which is of value 1, and we have used just 2 coins here, which is of value 6 and 1, right? So because this is one minimum one, right, when compared with this, because we have used a coin which has larger value 6, right? And morely, you can even use a single coin as well which has a value 7, right? That's also the case. So this is the requirement. So as you have seen, we are trying to use the coin which has more value, right? That's the requirement, right? So let's try to do that. Let's try to take the coins which has more value, and let's try to see whether we can form this amount or not, right? For example, here, starting with the largest one, which is 5, right? So let's start from here. So this is the largest coin we have till now. So 5, right? 5 is not exceeding this amount. So let's take 5. Let's take 5. Okay, one 5 rupee coin. So now, as they have said, we can use a coin as many times as possible, right? So I'm going to continue with 5 only, because I want to make sure I get minimum value, right? The minimum coins I have to use. For that, I have to take the coin which has largest value. So now I'll be taking the 5 again. I'll be taking 5. So now the sum is 10, right? Which is exceeding 7. We don't want that. We want exactly the coins which make up to 7, right? We want exactly 7, right? So in this case, it is exceeding. So what I'm going to do is, I'm not going to take 5 again. I'm going to come to the next largest one, which is 4, right? So I'm going to take 4 and I'm going to add this 4 rupee coin here. So let's sum up 5 plus 4. 5 plus 4 is going to be 9, right? So this is exceeding. This is exceeding again, which is greater than 7. We don't want that. We want exactly 7. So now I'll be removing 4 again. I'll be coming to 3. So 5 plus 3. What's the sum? It's 8, right? So 8 is also exceeding 7, which you don't want that. So we want only 7, until 7 only. So I don't want to take 3 again. So again, I'll be coming to 1. So now 5 plus 1, which is 6, which is not exceeding 7, right? So we are in the right path. So now, as we have seen, we can use a coin any number of times. So I'm going to use 1 again, right? So I'll be using 1 again. So 5 plus 1 plus 1, which is 7. So now we have got the amount, right? We have got the amount which we require. So this is a combination, right? So we have used the largest value coin first, and we have come down gradually, right? So now we have got 7. So now, do you think this is the combination which takes minimum number of coins? Do you think like that? Definitely not, right? Because this is one combination. Of course, this made us 7. This made up value 7, right? But there is a combination with 4 rupee coin and with 3 rupee coin, which would make 7, right? For example, if I take 1 4 plus 1 3. So this will make 7 as well. 3 is also a case, right? So now here we have used only two coins, but in this case we have used 3 coins. So we have missed this case, but we have got 3 coins, right? So based on this example, what you have got, so in this case what you have to do is you have to try to find all the possible ways, all the possible combination of these coins, and have to find the minimum coins which you have used in those combinations. So when you have got to do, when you have got to know that you have to perform all possible ways or all possible combinations, the first thing which comes to your mind is what? Definitely recursion, right? Recursion is the way where we can find all possible ways. So you have to recurse that, you have to backtrack and find all the possible ways, and if at all at some place or at some point, if the sum has made up to the amount, which in this case which is 7, then you can keep track of the coins which have used until that point, and you can find the minimum number of coins you can use. That's the case, right? So let's try to take an example, let's try to take another example, and let's try to see how can we do that, how can we do it recursively. So let's take this example. Let's take we have these coins which are of values 1, 2 and 3, right? And we also have a value called as amount where it is of value 3, right? So you have to use these 1, 2, 3 rupee coins, and we have to try to find the minimum number of coins we can use to make up this sum, right? So now what I have said before, I have said that we're going to use recursion. We're going to backtrack and find all the possible ways, and we have to find the minimum number of coins. That's the requirement, right? So now what I'll be doing is I'll be taking initially the value 3, right? So that's the one which we have got. So now when I decrement, for example, if I'm using 1 or 2 or 3, so that amount will be decremented, right? That the value which the coin contains which will be decremented. For example, let's take I have initially 3, right? So there are either 3 ways to decrement. There are 3 ways in this case because we are using 3 coins. Either I can use like 1 coin here, or other coin here, and other coin. So if I use a 1 rupee coin, which is this coin, so now it's going to become 2, right? Because if I remove 1 from this 3, it's going to become 2, right? Similarly, if you remove 2, it's going to become some value. If I become 3, it's going to become some value, right? If I remove 2, what is going to become? It's going to become 1. If I remove 3, it's going to become 0, right? These are the cases. So let's make it a bit good. So this is going to become like this, this is going to become like this. So now if at all the amount becomes 0, that actually means we have made that amount, right? That's it. Like for example, we have used a 3 rupee coin for this amount 3. So if we decrement 3 from this 3, so it becomes 0. That actually means we have got exactly the sum, which is the amount, right? In this case, we don't have to continue downwards because we have got 0. That's the case, right? So now I'll be continuing with the other nodes, with the other values, or with the other amounts. So now in this case it's going to be again the 3 combinations or the 3 coins usage. So I can use 1 coin here, I can use another coin. So even here as well I can use 3 coins. So in this case, if I use a 1 rupee coin, it's going to be 1. If I use 2 rupee coin, it's going to be 0. If I use a 3 rupee coin, it's going to be -1, right? Because it's exceeding. So now if I use, it's going to become like this, it's going to become like this, and it's going to become like this. So we have used a 1, we have used a 2, we have used a 3. So clearly, if you see here, when you have an amount 2 and if you try to decrement 3 from that, that actually means it's exceeding, right? Because if you have an amount 2 and if you try to use the 3 rupee coin, then that's definitely exceeding, right? So in that case, the amount becomes negative, right? Negative in the sense we don't have to continue with that. So now we can go with the rest of the values. So in this case, the rest of the values are 1 and 0, right? So if it is 0, as you have seen here, right, if it is 0, that actually means we have got the exact sum. So for example, let's see the path. So I've come from here, let's go backwards, from here to here, from here to here. So I have used a 2, I have used a 1. So 2 plus 1 is going to be 3, right? So it got the exact sum. So if the amount becomes 0, that actually means we have got the exact sum. So we don't have to go further even deep because that's going to become negative, which you don't want. So now let's go with the other values. So I can use 3 coins here as well again, which is a 1, a 2, a 3, right? So if I use a 1, it's going to be 0. If I use a 2, it's going to be -1. If I use a 3, it's going to be minus 2. Again, it went to negative. That actually means it is exceeding, because if you sum up this, sum the path, see we have come, let's go backwards from here to here, from here to here, from here to here. So 3 plus 1 plus 1, which is 4, which is definitely exceeding the 3, right, which you don't want. So that's why we have gone to negative value. Even in this case, 2 plus 1 plus 1, 4, so that's why we went to negative value. So now in this case it is 0, right? We are 0 in the sense we have got the exact amount, exact sum for the amount, right? So in this case we got the sum, which is 1 1 1, which is 3, right? So now let's continue from this one. We have left this one, right? Let's continue with this one. So if I remove 1 2 3 from these, so one value would be 0 in this case, right? So in this case it's going to be negative 1, in this case it's going to be negative 2, right? So for if at all, as we've seen before, if it is 0, that actually means we have got the exact sum. If it is negative, that actually means we are exceeding the amount, right, which you don't want. So you can stop there. So now we are done with all the amounts. We have documented, we have found all the possible ways. So in this case, wherever you find or where the amount becomes 0, there only we have got the exact amount, right? So what are the places? So this is one place, this is one place, and this is one place, and this is one place. Totally 4 places. So let's try to find the coins which I have used. So from here I'll see the coins. So I have used a 1 rupee coin, and I have used a 1 rupee coin, I have used a 1 rupee coin. So now the combination was 1 1 1, which is 3 coins, right? 3 coins. So now the other combination, which is this. So let's go backwards. This is 1 2 rupee coin, and this is 1 1 rupee coin, which is just 1 2 and 1. So just 2 coins. Similarly, so here this is one coin, this is one coin which is 1, this is one coin which is 2, right? So 1 and 2, again 2 coins, the other 0 which is here. So this is only one coin which is of value 3, so this is just one coin, right? So what are the minimum coins which I have used in these combinations? Of course it's 1, right? So that actually means using these coins, using this amount, the minimum number of coins which are required to make up this amount is 1. This is the answer. So this is how you find all the ways and you get the minimum number of coins required. So don't you think there is a repetitive process in this? Don't you think? Like for example, if I given you a question, or if the requirement is 3, right? So if the same coins like this only, let's say imagine I've given you this input for the first time, and you have done all the process, and you have got to know the answer is 1, right? You have got to know the answer is 1. And after some time, if I give you the same input with the same coins with the same amount, if I ask you what is the answer for this input, so you will obviously say it's 1, right? Because you have done already. You don't have to do again the same process again by doing all the recursion again, right? So if you see clearly, when the amount becomes 1 in here, you have done this process, right? You have done this process, and whenever again when you have come to this place which is 1 again, you are doing the same process again, right? Which is the same. So you have decremented 1 2 3, and you have got the same 0 minus 1 minus 2, 0 minus 1 minus 2, right? Which is nothing but a repetitive process. You're trying to do the same process again and again, which you don't want. So what you can do is, whenever you have got the answer, we have got this answer, the minimum number of coins that you're going to use when you have got this 1, right? So you can store at some place. For example, when you have come to 1, right, when did it become 0? After how many coins you have used, it became 0. So it became 0 only when you have used a 1 coin, right? Which actually means the minimum 1. So what you can do is, you can store at some place saying that if the amount is 1, the minimum coins required is just 1, right? So in that case, you come to 1 again like this. Instead of doing this three ways again, you can just take a value from here saying that okay, the amount is 1, which I've already seen here, and I can just return this 1 here, right? So let's try to take this example and let's do the recursive. Let's try to do that using that DP. This is actually called as DP, which is called as dynamic programming, right? I know you know this concept, right? We're actually trying to do memoization. So this concept of storing at some place and taking that is called as memoization, right? So let's try to take the same example and let's try to do exactly how we have to in the code. Let's try to see how exactly we are going to implement by taking the same example. So here we are having the same example with some which contains the same coins in the same amount. So here the coins are 1 2 3 and the amount is 3, right? So as we have seen before, we are going to use the amount 3, right? So this is the amount we are going to use. So now what we have done before, we have tried to decrement by using these coins, right? Let's do the same thing again. So initially there are three ways, right? Because we have 3 coins, so I can decrement in 3 ways. So firstly, I'm going to decrement by 1, right? I'm going to use a 1 rupee coin and decrement by 2. This is one combination. So now the amount became 2, right? Obviously we have decremented 1, so now amount became 2. So for 2 also I can use a 1 rupee coin again. So I'll use a 1 rupee coin, so the amount became 1. So now I'll come to I'll use a 1 rupee coin for 1 as well. So now the amount became 0. So as what we have seen before, so if the amount becomes 0, that actually means we have summed up to the 3, we have summed the value. So what I'm going to do is, I'm going to send, if at all the amount is 0, I'm going to return 0 to the top value. That actually means we have got the exact value. So in this case, if the amount is 1 and I've used a 1 rupee coin, that actually means I've got the amount 1, right? So I'll find other possible way as well. So you'll get what I meant exactly later. See, so I have used 1, now I'll use 2. So if I use 2, it becomes -1, right? So now if it went to negative value, what I'll be doing is, I'll be sending some maximum value. It might be some infinite value. Let's name it as m maybe. So the other combination is I'll be using 3, so it's going to become -2. So as I said, if I get a negative value, that actually means it's exceeding. So in this case, I'll be sending some maximum value, which is m. So now I'll come back to 1, right? Because I'm done finding all possible ways with this amount 1, which is 1 rupee coin, 2 rupee coin, 3 rupee coin. So I cannot go much further deep, because we have come to 0, we have come to negative values as well, so I can go deeper inside. So now I'll come back to 1 and see what are the minimum values we have got. So one value is 0, right? One is 0, one is a max value, another one is a max value, right? So what is the minimum one out of these 3? Obviously 0, right? So now what I'm going to do is, I'm going to take the minimum of these 3, right? The minimum of these 3, and add +1 to this. Why +1? Because that actually means we have used a coin, we have used 1 coin. So that's it. I think you got the point, right? So this is going to send the minimum number of coins we have used for this amount. So for 0, the coins which I have used is just 0, right? So when we come back, that actually means we are going a step forward. So that actually means we have to add +1. So for this one, the minimum number of coins we have used is 1. So what I'm going to do is, I'm going to store it someplace, maybe like this. For 1, the minimum coins we have used is just 1, maybe a map kind of thing like that. So now I'll come back to here, which is 2. So as for 1, it's just one coin, right? So now I'll be sending this 1 to here. So now I'm left over with 2 other combinations. For 2, I can use a 2. So now it's going to become 0, obviously, right? So now if it all is 0, that actually means we got the exact sum. So I can return 0. I think you got the point, right? So now there is another combination as well. So now it's going to be 3. Obviously it's going to become -1, right? So now when you come to negative value, right, so I'm going to return some maximum value. So I'll come back to 2, because I'm done with finding all the combinations with this 2, right? So what are the values we have got? So let's try to remove this. So now what are the maximum values? So for this 2, for this amount 2, so the minimum values I meant. So the values you have got are 1 and 1 0 and 1 maximum value, right? These are the values. So let's try to find the minimum of these. So the minimum is 1 0, right? So which is 0. So as we have done before, I'm going to add +1 to this. So now it is 1. That actually means we are adding extra coin, which is this 2. I mean this one, this extra path. I think you got it, right? So now the minimum number of coins required to make up this 2 is 1, which is 1 2 rupee coin itself. That's it. I think you got the point. So now I'm going to store again. That's very important. So for the amount 2, just one coin is enough, which is one 2 rupee coin. So I'm going to return the minimum of these three values plus 1. I mean just minimum of these three, which is 1, obviously. So now I'm left over with the other two combinations for this 3. So it's going to be 2 and it's going to be 3. So for 2 it's going to be 1, right? So now if I remove 2 from this 3, it's going to be 1. So now, as I said before, we don't want to do any repeating process. So don't you think we have done the same amount before, which is 1? How can you see? How can you know that? Because you can know that because we have stored here. So we have already a value 1, amount 1, which we have previously done, which is here, right? We have done here. So we don't want to do the same process again by decrementing 1 2 3, because we have stored already here. So what we can do is, if it is there here already, I can take this value and send this here. I think you got the point. So in this case it's 1, right? So now the leftover combination is using 3. So now if I use 3 rupee coin, I'm going to get 0, obviously. So now if I try to remove 3, I got 0. So if it is 0, that actually means we have got the exact sum. If it is 0, that actually means I'll be returning 0, right? So now what are the minimum values of these? Let's try to remove this. So now what are the minimum values of these? One is 1, which you got from here, from by removing 1, and the other value is also 1, and the other value is also, I mean it's 0. So what are the minimum of these 3? Obviously the minimum is 0, right? So when we find the minimum, we have to add plus 1, because we have to add the extra coin, right? So which is plus 1, which is 1. So we have got 1 here. That actually means for amount 3, the number of coins is 1. Right? We are done with the entire recursive process. We have come back to 3, and we are done with all the combinations. So now how do you find the number of coins which I have used for 3? We have stored obviously here, right? So what we can do is, I can get this value from this map or maybe some place, and just say get that value and return as an answer. So in this case the answer is 1, right? So what we have done, we have tried to do the DP approach, or we can say a memoization approach, and we have tried to store it someplace, and we didn't want it to do the same process again, and instead we have took the value from there and we have used that. So that's the approach. So this makes things very faster. Once try to do the previous recursive approach without trying to do the DP and try to run this, it's going to take a lot of time. You can obviously get a time limit exceed, but if you try to do this DP approach or this memoization approach, it would be a very fast approach. So let's try to implement this. Let's try to code this. So here we are having a method called as coin change, just like the question title itself. So it processes an array which is of name coins, and it passes an integer value as well, which is of name amount, which are the requirements, because we need coins and we need the amount, right? So they will be passing that. So what we have done initially, we have tried to do the recursive approach, right? We have tried to do the recursive approach. So for that, what I'm going to do is, I'm gonna use an extra method for that. So as you know, I'll be using a method name just every time, which is DFS. So you can use any other method name as well. So I have used DFS. So the parameters would be coins, which is a requirement, and the amount. So first thing, what we have done, we have tried to decrement, right? We have tried to decrement the amount with the given coins. So what I'm going to do is, I'm going to loop with these coins, which is coins dot length, and I'm gonna do the recursive approach by decrementing. So now with the coin, I'll be passing the coins. Now the new amount becomes amount minus the current coin, so which is going to be coins of I, right? So now this process continues till the amount becomes 0. So if the amount is equal to 0, I think you remember, right? I'll be returning 0. And there is another case, if amount becomes less than 0. When it becomes less than 0, only if the value amount exceeds, or if you're using a coin which is exceeding the amount. So if the amount becomes less than 0, as you have seen before, I'll be using a max value. So in Java, integer max would be a maximum value. So integer dot a max value, right? So now after getting some zeros and some negative values, we'll be returning them, right? So we have to store that, and we have to store that and get the minimum of those, as you have seen. I hope you got the approach before. So for that, I'll be using a minimum variable, and initially I'll be storing a max value for in this, right? So now I'll be taking minimum from this, and the return value will be here, and I'll compare that return value with this current minimum. So at last I'm going to get the minimum value of them, and what I have to do, I have to store that, right? Which actually, if I get the value here, if I find a minimum value, that actually means the minimum number of coins required to get or to sum up or to make up this amount, the current amount, right? So for that, first thing I have to make sure, if minimum is equal to integer dot max value, that actually means there is no way of making up this amount. For example, let's take for example, we have amount of 1, right? So, and similarly we have coins 2 3 4. So using this 2 3 4 amount coins, you cannot make up this amount, right? Because everything is exceeding. For example, you use a 2 rupee coin, it cannot be 1, because 2 is greater than 1, even 3, even 4, because there is no way of making up this amount. In this case, all of this is going to return, whenever you decrement 2 with 1, it's going to return a max value, because it would exceed, because 1 minus 2 is going to become negative value. It's going to return integer dot max. In this case same, so in this case the minimum will always be a max value, right? If it is a max value, we have to store that it is not possible, right? So if the minimum is equal to max value, just store it someplace. So for that, what I'm going to do is I'm going to create a map for that. So a map is nothing but a hash map. It's a key value type of data structure. You might know it already. So it's going to be an integer type. I'm going to name it as dp, and because we are going to use dp, so a hash map. So I'm going to store this. So dp dot put, if the amount is this current amount, the minimum number of ways in this case is integer dot max value, because there is no way, right? Else dp dot put if the amount is this amount, then we have to, the minimum number of coins we can use is min plus 1, because we have to add the current coin as well, right? I hope you got this point. So now return min is equal to integer dot max value. The minimum value is integer dot max value, then there is no way, right? Then just return just min, or else just return minimum plus 1. I think you got this point, minimum plus 1. So let's try to remove this, and at the end we're going to get all the possible ways, and we're going to store in this dp array, right? So now let's call this function. So let's store this into a result, and dfs coins and the current amount. I'm going to pass these two parameters, and at the end I'm going to get the result, right? So we have to see here, return if result is equal to integer dot max value, then that actually means it is not possible to make up this amount, right? I think you got that. So in that case, if it is not possible, we have to return -1, as they have given here, right? We have to return -1. So let's return -1. Or else, if it is not a max value, then we have got a particular min value, so we can just return this result. Yeah, this is pretty much the implementation of this. So I think you got this implementation. Let's try to run this. Let's make sure we don't have any mistakes like that. Okay, yeah, it got accepted. Let's try to use some extra test cases as well. So run this. Okay. Oh shit, I forgot a case. So when you reach up to a particular amount, you have to see whether you have already stored that, right? For that, I have to see it here. I forgot the main case. So if where we are going to store them, we are going to store in this dp map, right? So we have to see the dp map only. So if dp map dot contains key with this amount, then you don't have to do this again, the entire process again. What you can do is you can just get the value from that dp map. Return dp dot get the value or the minimum coins which you have used from this amount. So yeah, so I think even this works, because the reason why it worked here was the number of coins were less, right? So it doesn't take much time. So now let's try to submit this. Oh yeah, so see, it got succeeded. So now let's try to remove this. Let's try to remove this code and let's try to see what happens. Let's try to see how much difference it makes. Let's try to submit this. See, it's already taking a lot of time. See, we have got a time limit exceed because the amount is large, because it's going to form a big huge recursive tree, right? So it's going to take a lot of time. So for that, the reason why is, as we have seen before, is trying to do the same process again and again. So for that reason, what we have done is we have tried to store, here we have tried to store the values, and if at all you reach the same amount again, you are getting this the value from this dp map, and you're just returning that. So if you try to do this, it's obviously going to take less time and it's going to definitely going to succeed. So yeah, this is the implementation. This is how you use a memoization. So there might be another way of doing, using like some arrays like that, a single dimension array, but I felt like this is a classic, or this is like a foundational approach, because this approach exactly tells how can you memorize a particular thing, right? So I felt this was a nice approach, even though it takes more time. I felt this is a nice approach to understand how a memoization works. So if you like the video, please make sure you like and subscribe. Thank you.